Okay, we'll be going with the second paper now. You can look into the first question. This acceleration is given as 1. So I am assuming this, they never said this. Okay, this acceleration is 1, so this acceleration is also going to be 1. This acceleration is 1 given, this acceleration is 1 given, this acceleration is 2 given. Now I don't know what is this guy's acceleration, so I am calling it as x. I don't know what is this guy's acceleration, I am calling it as z. I don't know what is this guy's acceleration, I am calling it as y. Now I know this is one string, so there are 3 strings. This is one string, this is other string, this is other string. So I can write 3 string constants. So this guy's acceleration and this guy's acceleration must be same. So if this is y and this is z, both must be equal. So I am calling this guy also y because the string is inextensible. Now if I look at this part of the string, this guy's acceleration is 1 and this guy's acceleration is 1. So this length is not going to vary. This length is not going to vary. Now this guy's acceleration is x, this guy's acceleration is 1, so it is going to increase at a rate of x minus 1. So similar kind of, I can write velocities and I can differentiate it. So anyway you will be getting this as x minus 1. Now similarly this is moving with x and this is moving with y, so this is going to be extending with x minus y. Now similarly this one, this is going with 2 and this is going with x, so this will be extending with 2 minus x. This is going with 2 and this is going with y, so this will be extending with 2 minus y. But I know this is a single string, so this is a single string, so net extension must be 0. 0 plus x minus 1 plus x minus y is 0. This is for the first string. Now similarly for the second string, 2 minus x plus 2 minus y, that must be 0. So there are 2 variables, 2 equations, so you can solve for them. You will be getting x equals to 5 by 3 and y equals to 7 by 3. Then they are asking acceleration of block D. Acceleration of block D, yes, we can find from the acceleration of D and B. D and B will be same, so which is same as y, 7y3. Okay. Then end A is being pulled with what force? End A is being pulled with, so if this tension is T, then these two tensions will be T by 2 because pulley is massless, net force must be 0, T by 2, T by 2. If this is T by 2, this will be T by 2. If this is T by 2, this is T by 2, this will be T because net force on the pulley must be 0. If this is T, then this is going to be T. And if this is T and this is T, this is going to be 2T because the pulley is massless. So we need to find what is 2T. For that we can go from here. T equals to 1 into A. So T is 1. So 2T is that much. I can manage from here, right? Yeah. So T minus mg. T minus mg equals to 1 into A. So T equals to 11. If T equals to 11, then 2T equals to 22. Okay, that is fine. Now they are asking mass of block B. Mass of block B. So when you write the force on this guy, it is T minus T by 2 minus mg equals to mass into acceleration of this guy. Acceleration of this guy is 7 by 3 and tension is 11. So you can substitute the value, you will be getting the required answer, which is anyway not matching with the given thing. Okay, in the next question, I didn't write anything there. Yeah, you can see a molecule can have speed greater than root of 6 RT by m. See, molecules can be having any speed. We will be talking about only average or RMS because we can't look into each and every molecule. It is some random thing. When the temperature is doubled, then the most probable speed. So all the speeds will be proportional to root T. So it is going to become root 2 times only. Kinetic energy of 1 mole of monoatomic gas, you can write NCVT. CV is F by 2 or degrees of freedom are 3 for monoatomic, and for diatomic degrees of freedom are 5. So from there we will be getting option C is correct, option D is wrong. Okay, next question again. A strong bar magnet, yeah, it is being dropped and north pole of the magnet is always upwards and stuff. Okay, there is a copper block at the bottom. There is a copper block and you are dropping the magnet. There will be flux change keeping on happening. So there will be eddy currents and there will be like opposition coming into picture. Fine. So that much you can manage. Initially the opposition will be 0 because the flux is not changing. So initial acceleration is going to be g only. Now speed of the magnet, now what will happen when the magnet is falling, the flux will be keeping on changing, there will be eddy currents. So because of the eddy currents, like there will be opposition coming into picture. Whenever there is opposition coming into picture, the acceleration will be keeping on reducing, and at some point of time the opposition, like it's like when it is coming closer, the flux change will be keeping on increasing more, right? So the opposition will be keeping on getting more, so it will be even like going above the power of acceleration due to gravity, so it will be reducing its speed while it is coming closer. So it's like almost whatever is the potential energy available, which is mgh, it will be almost going as heat. Yeah, but we can't exactly say everything, but that's approximation. So going to the next question. Yeah, I mean, there is some object placed, so image will be formed there itself. In how many cases that is going to happen? Now, if the rays are going to hit the mirrors perpendicularly, so they will be retracing the path, so the image will be forming there itself. So this is going to be r and this is going to be r, so the distance between them is going to be 2r. Now what could be the other case? In the other case, the rays which are hitting here, like they will be hitting at the pole. Now if they are hitting at the pole, now you can see like these rays which are hitting here, like if the image is forming at the pole, then this ray will be interchanged with this ray and this ray will be interchanged with this ray. Now here rays are retracing, here rays are interchanging. In this case, the ray which is hitting here, it will go like this and it will be forming the image here. So now in this case, I will be using u, v. So 1 by u plus 1 by v equals to 1 by f. Now this distance is half of this distance. So object distance is minus d by 2, image distance is minus d, and focal length is minus r by 2. When you substitute, you will be getting d equals to 3r by 2. Now the other case is pretty simple. When you put out focus, the rays will be becoming parallel, and again if the rays are parallel, like the image will be again at the focus. So if this is focal length and this is focal length, then the image will be forming there itself, which is focal length is r by 2, focal length is r by 2, so r by 2 plus r by 2 r. Okay, the next question, it is sinusoidal. So I naught plus I1 sin omega t, I naught plus I1 sin omega t. So if you want to find the average of this, average of the left hand side equals to average of the right hand side. Average of I naught is I naught only. Average of sin omega t is going to be 0, because this is positive, this is negative, they will be getting cancelled always, right? Now similarly, I need to find IRMS square, so that is I square, average and square root I need to take. So I am taking I square, a plus b whole square expansion. Now I square average is, this guy's average is same, this guy's average is I1 square, this sin square average is half. Now sin average is 0, so I square average is this much. I need to find square root of average. So this is mean of squares, average of squares, mean of squares. When you take square root, we will call it as root of mean of squares. That is going to be option B. Okay, so I am drawing the free body diagram of this half part. Now when I draw the free body diagram of the half part, this will be tension, this will be tension. Now if I take any element, there will be its own weight downwards, and there will be normal in this direction perpendicularly, which is making an angle 45 degrees, because this is 45 degrees, right? Now this normal is in this direction, so it will be having some vertical component, some horizontal component. Now I can't show you for all the things. It is like at this point normal is in this direction and this direction, but if I take the next element, it is going to be this way, right? So horizontal components are changing its direction, but vertical components are in the same direction. So what I can do, I can say all the vertical components. If all the vertical components are I can sum, and I can call it as n by root 2, then I can call it as n by root 2 will be balancing the weight. Now similarly, these n by root 2 components, they are like changing its direction. It's going to act like surface tension. So what I can do, I can go with surface tension times of effective length. I will be going with, that is force per unit length. That length is pi r, right? So force per unit length is going to be n by root 2 by pi r. Force per unit length times of effective length is 2r. I know it is going to behave like surface tension, so I am going with surface tension times of effective length. Now that force will be balancing 2t. So net force along vertical direction is 0, net force along horizontal direction is 0. From there, tension is going to be mg by 2 pi. Now if I know tension is going to be mg by 2 pi, I can get the energy stored half into stress into strain into volume. Strain is stress by Young's modulus. Tension we know from there, so you can substitute it. Now this is the potential, this is the elastic potential energy stored, which must have been come from drop in gravitational potential energy. Okay, in the next question, and this is fixed and this is rotating. So there is soap film here. What will happen? Soap film will try to pull it. So because of that, there will be rotation. So if I look at this rod, now the surface tension force, there are two interfaces. So when you go from this side to the other side, there will be two interfaces. So due to one interface, the surface tension force will be like, if I take at a distance x, the small element is dx, then the surface tension force because of one interface will be Tdx, because of the other interface will be Tdx. So totally it will be 2T dx. Now I want to find the torque. So that is x into 2T dx. Now if I want to find the total torque, I need to integrate from 0 to r. That is the total torque because of surface tension. Now by the time because of the torque, what will happen? It will keep on increasing its angular velocity. So the maximum angular velocity will happen when it is just before hitting. So torque into angle rotated, that is the work done. Torque into 2 pi. Work done equals to change in kinetic energy half ml square, moment of inertia, ml square by 3, that is mr square by 3 into omega square. Work done equals to change in kinetic energy. From there I will be getting what is the maximum omega. Now in the next case they are saying if there is magnetic field, what is going to happen? Now surface tension torque will be trying to pull it this way. If magnetic torque is trying to pull it this way, then it can be in equilibrium. They said like after achieving some small, within short time it is achieving that omega, and after that it is moving constant omega, they are saying. So again, torque due to surface tension must be balanced by torque because of the magnetic force. When it is going this way, there will be current flowing this way. If the current flowing is this way, then there will be magnetic force. All those things we can calculate. So we have calculated what is the torque because of the surface tension. Similarly, we can integrate torque because of magnetic field, and if they are equal, then the angular velocity will remain constant. If I want to find what is the torque because of magnetic field, I need to find what is the induced EMF. I need to find the current. If I know the current, then I can find the torque. Torque is going to be x times of that force, I into dx into b. So when I integrate this, I will be getting what is the torque because of the magnetic field. We have already integrated torque because of surface tension. Now we have integrated torque because of magnetic field. Torque because of magnetic field must be equals to torque because of the surface tension. Torque because of magnetic field equals to torque because of surface tension. From there we will be getting what is the value of omega. So they are asking what is the flux because of this charge through the like non-conducting sheet. So through the remaining part, it's like if there is a charge here, then the flux through this total side is going to be 1/2, and through the upper side is going to be 1/2, right? So if there is a charge, then the flux through infinite sheet which is placed below it is going to be q by 2 epsilon naught. Through the above sheet it is going to be q by 2 epsilon naught. So through the total sheet which is placed below it is q by 2 epsilon naught, but out of that we need to see how much is missing here, right? So out of q by 2 epsilon naught, how much is missing here? That is what is the flux through this disk. Flux through this disk is q by 2 epsilon naught into 1 minus cos theta. Theta is going to be 45 degrees. So flux through the sheet is going to be this much, but flux through the disk is going to be this much. So I need to subtract them. That will give me what is the flux through the remaining part of the sheet. Now similarly, if you want to find the force on this guy, find the force because of the sheet and subtract the force because of the disk. Force because of the sheet, field because of the sheet is sigma by 2 epsilon naught. Field because of the disk is going to be sigma by 2 epsilon naught into 1 minus cos theta 1 by root 2. So this is the total field. Field because of sheet minus field because of disk. Now that is the total field acting there into Q. That will give us what is the force. So that is the force that will give you mass times of acceleration. From there you can get what is the acceleration. Right? That flux is Q by 2 epsilon naught into 1 minus cos theta. Similarly, field due to disk is sigma by 2 epsilon naught into 1 minus cos theta. In the next question, a sample of helium plus ions. It's taking, okay. So helium plus, so I am looking at the energy levels. So energy of the system is going to be 13.6 into z square by n square. So which is 54.4 by n square. So I am just looking at the magnitude. If n equals to 1, it is going to be 54.4. n equals to 13.6, 6.04. I am looking at the difference 40.8. This 7.56. This is 48.36. This is something given in the question. So what does that mean? When a photon is given to that helium plus, it will be going from n equals to 1 state to n equals to 3 state. Okay. Now it went to n equals to 3. The maximum wavelength of photon emitted when helium plus returns to their ground state. So it is here. So when it go back, they are asking what is the maximum wavelength. So what is the least energy? Least energy is going to happen when it is going from 3 to 2 or 2 to 1 or 3 to 1. So that is going to happen when it is going from 3 to 2. So they are talking about this thing. So when there is a energy gap, when it goes from n equals to 3 to n equals to 2, what is the wavelength of the photon emitted. So what is the energy of the photon? 7.56 nano or 7.56 electron volt. So that is 1 hc by lambda, where hc is 1240 when lambda is in nano, right? So from there we will be getting lambda is approximately 164 nanometers. Now the minimum de Broglie wavelength, again minimum de Broglie wavelength in the sense h by lambda momentum has, okay, for photoelectron, so momentum has to be minimum. If momentum has to be minimum, wavelength has to be maximum. Wavelength has to be, okay, they are asking minimum wavelength. So for minimum wavelength, momentum has to be maximum. So for what case the momentum is going to be maximum? So momentum of the electron has to be maximum. So like it went to excited state, n equals to 3. Now if the electron's energy has to be maximum, then it must be taking maximum energy from the photon. So what is the maximum energy of the photon? 48.36. So for that situation of maximum kinetic energy of the electron to happen, it needs to take a photon of energy 48.36. Now helium plus has taken photon and it got excited. Thereafter there will be de-excitation and it will be emitting 48.36. Out of that, 6 will be going as per function, remaining will be kinetic energy of the electron. That is the maximum kinetic energy of the electron possible, which is the condition they are talking about. Now that maximum kinetic energy of the electron, I can write it as p square by 2m of the electron. P is h by lambda. I can substitute those values and I will be getting the required answer. So momentum is h by lambda, that's the only thing, and energy is hc by lambda in case of photon, p square by 2m, that is h by lambda whole square by 2m in case of electron. Okay, in the next case they are telling something like this. So when you are connecting these two by a wire, then the current in this one is going to be 50 milliampere. When you connect these two by 15 ohm, then the current in this one is going to be half of that, 25 milliampere. That's what they have given the question, like half, right? Okay, so we'll see what is going to happen. Now if I take this as zero potential, this will be 1.5. Now this current is 50 milliampere, this resistance is 20 ohm, so I into R, the potential difference is going to be 1. So if this potential is 0, this is going to be 1. If this is 1, this is 1, this is also going to be 1. Yes, so this is 1.5, this is 1. So I can calculate what is this current. This current is 1.5 minus 1, which is 0.5 by R2. Now this current is going in this one and in this one. So what is the current in this one? 50 milli. What is the current in this one? Potential difference by resistance. So this current equals to this current plus this current. Now similarly I can do the same thing here. Now I can find the potential difference. Potential difference is going to be 0.5. So if this is 0, this is going to be 0.5. If this is 0, this is going to be 1.5. Now this current is going to be 1.5 minus 0.51, 1 by R2 plus 15. Now that current will be going in this one, which is 0.5 by R1 plus 25 milli. So these are the two equations. I need to solve them. I can see if I multiply this thing with 2, I will be getting this. So 2 times of this is going to be this. When I solve it, I will be getting R2 is 5. I can substitute R2 is 5 here and I can get R1 as, okay, vernier calipers. They have given the first figure. So you can see this is 2.5, 6, 7, 8. It is more than 2.5, less than 2.9. So we need to find what is that extra length. So coinciding thing is this thing. So I will be measuring the length from here. 1, 2, 3, 4, 5, 6, 7, 8. 8 main scale divisions equals to x plus 1, 2, 3, 4, 5, 6, 7, 8. 8 vernier scale divisions. 8 main scale divisions equals to x plus 8 vernier scale divisions. From there x will be 8 main scale divisions minus 8 vernier scale divisions. This is given in the question. 1 main scale division is 1 mm and 10 vernier scale divisions are equals to 9 main scale divisions. From this I can calculate 1 vernier scale division is 0.9 mm. So you can substitute those and you will be getting x value as 0.8 mm. Once you get x value as 0.8 mm, then the answer is going to be 2.8 centimeter plus 0.8 mm, which is the required answer. Now in the next case also we will be going by the same thing. This information is given in the question. This is not our regular vernier scale. Now again, this is the extra length I need to measure. So 1, 2, 3, 4, 5. 5 main scale divisions equals to x plus 1, 2, 3, 4 vernier scale divisions. X value I will be getting if I substitute it. Once I know the x value, the answer is going to be 2.8 plus x, 2.8 centimeter plus x, right? See, notice one thing here. This is our regular vernier scale. It's like n vernier scale divisions will be matching with n minus 1 main scale division. This is our regular vernier scale division. In this case, 8th division of main scale will be coinciding with 8th division of vernier. So these two numbers will be same. That is the good thing about our regular vernier scale. But here, it won't be the same number. That we need to take care. Okay, you know resultant amplitude will be like a1 square plus a2 square plus 2a1 a2 cos phi. So intensity is proportional to amplitude square, so I can write the same equation as resultant intensity equals to i1 plus i2 plus 2 root i1 root i2 cos phi. Now the same thing I can write it as this, like using that trigonometric properties, right? Now maximum intensity will happen when this is 1, so this is maximum intensity times of cos square phi by 2. Now they are asking, so in which all cases it is going to become 3 by 4th of the maximum intensity. So for that this one has to be 3 by 4th of the maximum intensity. So cos square phi by 2 is 3 by 4. So cos phi by 2 is plus or minus 3 by 2. It will happen for what all angles, 30, 150 and so on, but they are asking when it will happen for the second time. So I need to bother about this guy. So phi value is 300 is 5 pi by 3, right? 300 degrees is 5 pi by 3. So in the next question, they are asking what is the resistance we need to connect here so that the maximum power will be transmitted through this. So we know the maximum power transfer theorem, it must be equals to the internal resistance. So what we will do, we will use Thevenin's theorem for simplicity. So what does Thevenin's theorem say? If there is a load and if the remaining part consists of only batteries and resistors, you can replace it with a single battery and single resistor. How to find that battery? Open the load, find the potential difference here. When you open the load, and if I assume this has 0 volts, this will be 0 volt, this will be 5 volt, this will be 8 volt. No current will be flowing through this. So I can find what is the current in this. It is 8 minus 5, potential difference is 3, by the resistance is 9. So current is going to be 1 by 3. If the current is going to be 1 by 3, potential difference here is going to be 1. So if this potential is 8, this potential is going to be 7. This is 0 potential, this is 7. So Thevenin's voltage is 7 volt. Now if I want to find Thevenin's resistance, short circuit the battery and find the equivalent resistance across this. 4 plus 2, 6, 6 and 3 parallel to 2 and 2 series 4. So Thevenin's resistance is 4. So what you can do, you can replace this entire thing with 7 volt battery and 4 ohm internal resistance. 7 volt battery and 4 ohm internal resistance. Now if the maximum power transfer must happen in this one, then it must be equals to internal resistance, or you can do by differentiation and you can get it. So R must be equals to 4 ohm. Okay. So in the next case, see, deviation through the lens. Deviation through the lens is constant thing, but it is easy to find for a parallel ray. So if there is a parallel ray, it will be meeting at the focus. If it is coming at a height h, then the deviation is tan delta. Tan delta is going to be h by f. So when the angle is small, then delta is going to be h by f almost. So that is the deviation. For any ray, that is the deviation, but for parallel ray, it is easy to find. So the entire question lies on this. So now there are lens like this. So what I understood is, the ray is going to form a closed path, they said. So the ray has to be parallel to this regular polygon. This ray must be parallel to this regular polygon. That's what I understood. So this ray is parallel to this regular polygon. Now after passing through the lens, there is a deviation. Now that deviation must be same as bending of this polygon. Now that bending angle of the polygon is going to be, now these two angles will be small, same. So this bending angle is going to be same as this angle, which is how much? 18 degrees. So the deviation has to be 18 degrees. If the deviation through the lens is 18 degrees, then it is going to follow exactly the same structure as that regular polygon. So deviation h by f, focal length is given 10. So deviation must be same as 10 degrees. 10 degrees in the sense we need to go with radians, right? Only then tan delta is almost same as delta. So 18 degrees is 18 into pi by 180 radians. From there we will be getting h as pi. So this value is pi. Now if the radius is r, so this is like arc length. I mean, I can approximate it to arc length, or I can take r sin alpha by 2, r sin alpha by 2. So it is going to be r alpha. So this length is going to be r alpha. This length is going to be r plus h into alpha. So r alpha, and this distance is given as same as focal length in the question. I think the wording is not good, but they try to mention like this length is same as focal length. Okay, so r alpha is equivalent to focal length. From there I will be getting the radius. Now if I know the radius, they are asking what is this distance. It is r plus h into alpha. They never asked r plus h into alpha. Okay, they are asking what is the radius of that circumscribed thing. So now this one can be fit in a circle of radius r plus h. So they are asking r plus h. So r alpha equals to f. So from there we will be getting r. So once you know r, you know h, then you can calculate r plus h is approximately 35. Right? Thank you.